Hi everybody, thank you for joining us today to hear about innovation for the water industry. Today our speakers will be introducing artificial intelligence and what it can do for water and wastewater treatment. My name is Ben Hutchins and I am part of the marketing team here at Innovise. Let me now introduce you to your speakers for today. Firstly, James Legui, Director of AI Products at Innovise. James is a technology executive who has worked across the water, transportation, education, medical and wireless industries for the past 15 years. He has launched products to millions of customers globally in the enterprise, SaaS and hardware sectors. James lives in Waterloo, Ontario, Canada and holds a BMath in computer science from the University of Waterloo and an MBA from Wilfrid Laurier University. Thank you for joining us today, James. Your second speaker needs little introduction for those of you who know Innovise well. Andrew Walker is a regional sales manager with Innovise in the United Kingdom. His career has been spent specializing in the computerized hydraulic analysis of drainage and flooding. He now has over 35 years experience of modeling the key aspects of urban drainage design and analysis. Thank you for joining us, Andrew. As we progress through this session today, please do ask us questions via the GoToWebinar interface. If we don't get to your question today, it would be great to have you join us next Thursday for a follow-up water talk on artificial intelligence, where we'll be answering questions live and in more depth. I'll add details to the group chat shortly so you can reserve your place and join us for this event. And now, without further ado, let's get to know more about what artificial intelligence can do for water and wastewater treatment. Andrew, over to you.
Thank you very much indeed, Ben, and good afternoon, everybody, and welcome to you from wherever you're joining us today. It's great to see as many people joined up as we have today. Just a quick summary of the points that we're going to cover during today's webinar. As Ben mentioned, we are going to be focusing very much on how artificial intelligence can help water utilities reduce their OPEX costs while maintaining compliance with regulatory standards. And those two are the most important points really about the system and what it's trying to achieve. So we're going to focus in today particularly on how our artificial intelligence tools work within a water or a wastewater utility situation, and we will be focusing, as Ben said, very much on the organizations that run plants within those particular remits. We're going to investigate how AI is implemented and show you or take you through some examples of how that is done. And then at the end, we're going to show you and introduce you to some tools that Innovise have developed, which will help you decide for yourself if you have a site which would qualify for artificial intelligence and which, if it did, would help you reduce your OPEX costs while maintaining compliance. Okay, so thinking about our operators and what their job is. Operators of plants are essentially faced with making a lot of decisions, and very often a lot of those decisions have to be taken at quite short notice. Now that can be a problem because at any given time, as I mentioned just now, the plant must be run to regulation and it must be held in compliance. And that means that when the operators are actually taking these decisions, very much it's the case that the decision to perhaps turn on a pump or turn off a pump, or perhaps turn on a blower or turn off blowers, decisions like that have to be made at the moment very much on judgment and experience. So it's very much down to the operators to determine the level of chemical dosages that are being used perhaps, or to decide when would be an appropriate moment to perhaps take part of a plant offline so that maintenance can be conducted, and particularly on critical assets such as membranes and things like that. So as I said, very much at the moment those decisions are driven by human judgment and experience, but things come along which can trip that decision-making process up. And in particular, things like extreme weather events leave systems vulnerable, very vulnerable, because they're not necessarily something that happens on a regular basis, and so there won't be the history behind it. Constantly changing conditions are probably the biggest enemy actually of any plant. Consistency is really key, and Added to that, we have the problem of things like aging infrastructure as well, where over time, as the assets in a network or in a plant degrade, they are less able to cope with extremes. And that can put the whole system under a lot of stress. Now, the way that we attempt to tackle that particular situation with the software is to provide a system based on artificial intelligence, which brings a degree of operational intelligence to empower the people who are actually operating the plants. And what that will do, and most importantly what that does, is to provide the plant operators with a decision-making process which can be done in real time. Okay? And that's really important because it means when these unexpected events come along, the system that you're using is able to react very, very quickly to that process, and you're able to make operational decisions much, much faster and with much greater confidence. Now, in terms of the decision-making process, that often gets based on 3 or 4 quite important parameters. So the sort of things that we're talking about here are trying to save on our OPEX costs, and we can do that primarily based on energy savings. It's not necessarily easy, but it's the easiest one of the parameters that we will typically be looking at. So how can we save energy by controlling our pumps more efficiently, by controlling our blowers more efficiently? And that's our number one pointer. Then we can move on and look at the other aspects of treatment plants. So we can look perhaps at more efficient and more optimized use of chemicals in the plant. And if we're using less chemicals, or if we're using them more efficiently, then obviously we're going to save money there. And certainly last but by no means least, if we can extend the lifetime of our assets in our plant by making sure they don't get under stress very often, then we will reduce downtime in our plants. And that will help us generally improve our process of maintaining compliance within that site without sacrificing level of service, which of course is really, really important. And very recently, certainly here in Europe and the United Kingdom, and in fact worldwide, we've seen another extreme event, which is of course the COVID situation. And in that situation, we have seen plant staff needing to be redeployed into other activities at very short notice. And of course, if the plant has the aid of artificial intelligence, it means that staff with experience can be deployed to critical areas of the organization, while other staff who perhaps don't have the experience to make those decisions based on their history of service can use the predictions from the AI system to help guide them to a successful conclusion. Now, what I'm going to do at this point is to hand over to my colleague James, which Ben introduced earlier, and James is going to take us through, first of all, a case study about how the system is deployed, so what we call a use case, so to put it into the perspective of an actual deployment, and then he will follow that up by looking at what's actually involved in implementation of an AI system. So I will keep my eye on the questions section, and then we'll take a break perhaps in a couple of slides' time to see if there's some questions, and I can put those out to you live. In the meantime, please, James, it's over to you.
Awesome. Thank you, Andrew. So let's talk a bit about how we could actually implement AI at an example use case and get an idea of that. So let's start with Joe. Joe's based in the United Kingdom. He's a wastewater plant operator. So we're going to think in that context about how we apply AI. So here's a very simplified view of how Joe's treatment plant operates. He's got influent coming in. Maybe he's got some alarms coming in on SCADA that he's got high influent flow. He has a biological treatment process there. He's got a good sensor coming out of the current level or current concentration in that clarifier. And then in the secondary clarifier, he's also got another sensor there. So he's got good sensors in his network. He also sees an alarm with high ammonia coming out, so that's not good for him. That's going to cause a regulation non-compliance issue on coming out as they discharge to the river. And then, of course, they're driving the air blowers and designing dissolved oxygen into that biological treatment process. And he's also got sensors on those blowers, so he knows when they're on or they're off. And then finally, he also has a return flow and a sensor on that return flow. So his network, his system, and his plan is actually pretty well instrumented. He's already got lots of data on how it operates, but he's seeing some issues kind of coming in on influent and effluent. And how does he manage that? So the reasons he's got those issues is that, as Andrew alluded to, climate change has kind of increased regulations for his plant discharges. We see this very commonly with customers that a lot of climate change is driving their regulations to become tighter year over year over year, and it's a continuing tightening cycle as they look to improve. So he doesn't want to be penalized by OPWAT or the EA. So Joe basically overuses energy and chemicals to always be ensure and be safe that he's never being penalized. But however, he's getting pressure from management overhead, rising cost of operations, the rising cost of energy and chemicals. It's not helping the bottom line. So how does Joe manage that, given that the pressure is coming from above and the operational pressures he has? And so the way Imagine AI works is we go from reactive. So Andrew kind of mentioned you're going to be always kind of reacting based on your historical knowledge of how to operate your pumps or your blowers. But how do you swap that and say not just reactive, but now I'm using predictive control? So as Joe, I now have predictive recommendations coming in from the Imagine AI of how to operate, and I compare that with my historical knowledge. So it's not just me relying on a split second recalling what I did 5 years ago. So for example, we say the Imagine would predict there's a high sewage load coming into the wastewater treatment plant. So given that, it would recommend a cost-optimized control schedule to handle this. So that commonly will mean it will schedule the blowers appropriately. It may drive a bit more dissolved oxygen right now in advance of that sewage load coming in to be able to handle that. But it also provides recommendations beyond that. So generally we'll say run these blowers at the peak, but minimize them overnight is an example. We take into account the energy tariff. So if there's a different structured energy tariff for your plant, that will be taken into account in the AI. And once it knows that, it can intelligently run the blowers when it's the cheapest to do that. That's one of the real simple explanations of we say how the AI optimizes. There's a lot more going on under the covers, but that's one we can relate to. And then ultimately, what Joe sees is those control recommendations that he follows now save him 30% on energy OPEX. And there may even be additional room for optimization here if we help Joe out on chemical optimization as well, if he had a chemical dosage set point. So it's been really interesting what Joe has done. We see this with operators across our customer portfolios. They're pretty surprised at sometimes the energy savings they can achieve. A lot of times folks think, we've been doing this for 10, 20, 30 years, and we've already done as much optimization as possible. But like we have come to learn, AI can usually find additional room, additional things that maybe humans didn't perceive before. And because the AI is also taking into account large data sets, like the energy tariff dynamically all the time, like the weather forecast dynamically all the time, even local events that are happening in your area, it's able to process that ongoing in real time. A human may be able to do that at a point in time, but continually doing that minute over minute, day by day is challenging for a human. So it really augments your intelligence of that operator is what we've seen. And so some folks may ask, well, this sounds great, but like, how easy is it to actually adopt this? And some of the advantages we have here is the comment is AI is also self-adjusting. We're always adjusting to the environment. So Andrew kind of mentioned the real-time changing conditions, and the AI is actually helping you there. It will see those system and environmental changes happening in real time via the forecasts of them, and it will start pre-adapting to them before they get there for you. So you're already prepared before it even happens. And that's an interesting one we do. When it comes to the current situation in our global world, with COVID, we can do a remote install completely of the product. So we don't even need to come on site to your facility to install the product, which is amazing nowadays. And we have remote access for all users, not just for the Innovyze folks, but also for our users of the product. You can access it anywhere. It's a SaaS-based product. It has security, full security on it, of course, all the way from the data ingestion process to the actual operators viewing the dashboard and getting the recommendations. But this has really enabled a lot of our customers to be able to access this remotely where they have maybe limited staff on site or restricted staff on site. So this has really opened up their ability to operate during this current situation. And finally, the way we sell the product is we allow you to kind of conserve costs on your existing budget. So the cost of the software is part of the savings that you're achieving. So you're not spending more money than you have in your current budget. So you can actually purchase the software on your existing budget and not have to require a new budget. So Andrew, maybe I'll pause there briefly before we switch into implementation, see if there's any questions that have come in.
Okay, thanks, James. Yes, there is actually. Thank you, everybody who's been putting your questions in. There is a lot of questions that have come in, and what we will do, if we don't get a chance to go through them all, we will obviously get back to you individually with a specific answer to your specific question, which we'll do post-event if we can't answer them here. But let's let's take top 3 questions at the moment. So the first question was, how does the AI system integrate with systems such as SCADA or others in a modern network, and what is the safest implementation of AI?
Yeah, that's a really good question. So SCADA is an absolute necessity actually for AI. It's an enabler for AI to actually work. One of the key things that the AI needs, or any AI needs, is to train itself on how to operate. So to do that, usually when we start, we'll gather 2 years of the historical data, usually from your SCADA historian, and use that to train the AI. And then since the AI is adapting in real time, we also hook up a real-time data connection to your SCADA historian. So we're always getting that data. Now, that leads to security, right? So we will integrate easily. We generally let the user control the security of the data coming out of the SCADA historian. So the customer usually can control when and how the data comes out. Commonly, we'll ask for every 15 minutes. But we let the customer securely push that to a shared secure location in the cloud. And the customer chooses how and when that happens, and their IT is fully in charge of that. So that's how we manage security on site. So the software doesn't actually come into your network, so you have full control there. And then once it's in our network, how we manage security, so we use Amazon Web Services. We use all the security controls they have in place there, which is amazing. We have a virtual private network set up, so once data is inside the system, it's fully secure. The only way to get to it is through the web dashboard, which is secured with SSL and the login. And we also, beyond just security, we also regionalize the data. So for GDPR, for example, we have a region in AWS in the EU. So your data never will leave the EU once it's at rest, which is an advantage there. So that's how we kind of, A, integrate with SCADA, and B, also cover off the security aspect of the deployment.
Fantastic, thanks, James. And related to that, somebody else has asked, thinking about the inputs to the AI system, is there any possibility of integrating AI predictions with the outputs of live modeling systems, such as IW Live in the case of water networks, or ICM Live in the case of sewer networks?
Yeah, that's another great question. So that's something we, ever since we've been chatting about Innovyze for the last 6 months about how we leverage the AI with our product portfolio. That is one of the biggest, probably the biggest use case we've identified that we're working on the roadmap, is how do we leverage that live modeling data? And there's a lot of great use cases that we can do there. One of the big ones that's come up is we can use the live model to simulate water quality down to a very specific pipe level. And that's an advantage I think we're going to leverage with the Imagine AI. So as we start working with networks, we'll leverage that model to ensure the water quality meets your compliance requirements at a very low level before we provide those AI recommendations. So we can fully validate those recommendations and the impact they'll have on the network, leveraging that live model, which is a very exciting opportunity for us that we have coming up on the roadmap in the near future.
Fantastic, thanks, James. And this one's come up a lot. It's been asked in different ways, but it boils down to, it seems like so far the discussion has been very much around treatment plants. Does the AI software also work for distribution or collection systems, networks in other words?
Yeah, exactly. So as I kind of alluded to, I think the system absolutely does. I think what we've seen in the market is that 2 things I'll say on when it comes to water networks. So first, we absolutely can work with networks. I think to make that happen, we need 2 things. One, we need the network to have a good sensor and also a remote control in the network. Since the network is widely distributed, the AI is going to recommend different pumps coming on and off. So an operator will need the ability to remotely control those pumps in an efficient fashion so they can actually implement the recommendations, firstly. And then secondly, like I mentioned, I think knowing the impacts at a network all the way down to the pipe level is something that's needed for the AI, and to do that, we'll need a live model. So we envision a future where the AI is leveraging the live model dynamically as it generates its recommendations, running simulations, ensuring that water quality parameters are met as one example, and then delivering those recommendations with the customer being fully trustful that everything has been taken into account, the live model's been run, and everything's been validated before we deploy. So those are the two ways I think that will enable us to really drive and work well with networks.
Fantastic, thanks, James. A lot of the other questions are all around people asking about how the system is actually implemented, which of course is what we're just going to move on to now. So what I'll do is I'll let you take back the presentation, talk a bit about the implementation, and then we can, I think that will cover off quite a few of the questions that are coming in at the moment. Thank you everybody who has asked questions. Please do continue to do so in the little questions box on the go-to control panel. But James, back to you. Thank you.
Perfect. Thanks, Andrew. Thanks for the questions. So when we look at AI implementation, it's always a question that comes up. People are like, okay, this sounds good, but how does it actually get implemented, and how long does that take, and what needs to happen? So here's a very quick view of how we do an implementation. So firstly, we would define success criteria up front. And so if we zoom back quickly to what Andrew talked about when he said there's 4 criteria: energy, chemicals, compliance, and membrane optimization. Define which of those we're trying to achieve for this specific site. So we'll define that up front. We do an installation process. This installation process, as I kind of alluded to a bit before, was we'll gather 2 years of your historical data. 2 years is preferable. You can do it with less, depending on what you have. And that's obviously required just to train the AI. It's very, very critical that we train the AI how your system operates so it can respond to it when we optimize it. We'll also do, in that installation process, hook up the real-time data connection to your SCADA. So we'll work very closely with your IT department to ensure we follow the right security protocols and operational protocols, and integrate with and get data from your SCADA system in real time. And then our team will take over in parallel here and start building the AI models, deploying the models, testing them, validating them, all that good stuff. That will happen during installation. And then we'll get to a POC period of about 30 days where we'll run the system live with your team. You can use it to the product for 30 days, and you basically can assess if the success criteria are met. So if that means we're trying to reduce energy by 20%, can we prove that we reduce energy by 20% in that 30 days? We're very confident we can, and that's just why we're offering a proof of concept over that time. So we'll get to the end of those 30 days. We'll evaluate, did we meet the success criteria or not? We have a price guarantee based on that performance, so that's very interesting. We're very excited to offer that we basically get to the end of the POC, and if we couldn't save you 20%, but it was 19%, we adjust the price accordingly to make it match, and then we go full live from there, and then we start operating in production with your team. You're taking the recommendations. We have KPI goals. They're always tracking what is the OPEX savings you're achieving, what is the goal. So that's always tracked live on the dashboard and via reports coming to you daily or weekly, depending on your position in the company. So that's a bit about high level about how the implementation goes. But if we dig in a bit more about how the data integration goes. So the question earlier was, how do you integrate with SCADA? I didn't go into a lot of detail, but I'll talk a bit more here. So like I mentioned, once you're inside the customer's network, of course you have your SCADA system on probably one machine. And you likely may have your historian on a separate machine for security reasons, and we don't want to touch that. But what we recommend to most of our clients is from the SCADA historian machine, once every 15 minutes, pull the last section of data from the system to kind of a staging machine inside your network. Once you've pulled that data to that staging machine, then you open that staging machine up to the internet and push the data out to our secure cloud. And this usually keeps a good separation of your SCADA system separated from your SCADA historian, separated from the machine that actually pushes the data out. And then you've got great control over what can't access the internet inside your facility. But gives you the ability to actually push that data out to the Imagine AI software in our secure AWS bucket. So we push the data out to the private cloud, and once it's there, then Imagine can start working. And this is a common way we've integrated with a lot of our customers. Most of our customers like it because their IT departments love it because they get to control fully what's going on in the network. They don't have to change any of the way they operate because we're there. If you don't have an IT department or you're kind of outsourced and you don't have a lot of resources available, we can certainly help do the implementation in your network. It really depends on which you prefer. And even in some instances, if you happen to not have a SCADA historian, we do have solutions where we can basically create one for you and create that data push to the cloud as well. So we kind of serve all the needs that we've seen in the marketplace, but most commonly we work with your IT department to make sure that partnership is solid. So okay, that's great. So now the data is up into the Imagine AI software, but what actually happens after that, and how do I get the recommendations? So given that we have your SCADA data, and we may actually have additional data too, we may have maybe some of your maintenance records from your CMMS system. We may have some lab sample data from your LIMS system if we're optimizing chemicals. And then we're also ingesting weather data and other local events. Of course, some of the weather data comes from a weather station source, and then any events we program in manually. An example of the events is we actually have a customer in the UK, and when there's a derby, or when there's actually any EPL match, to be honest, water usage spikes and then collection spikes as well, as you may not be surprised by. So we actually programmed the EPL schedule into the system, and the AI takes that in because it knows, it has learned that when there is an EPL event, there's this type of usage pattern. So we programmed that event schedule in, and it really helps drive the AI. But once we get all that data and we churn on it, so every 15 minutes we'll get a new set of data of kind of what's happening in the system. The AI will read that data, run it through the models, and say, okay, has the system changed significantly from the last time I ran? And if it has, I'll provide a new set of recommendations on how to run. So if influent to the plant is spiked, for example, since last read, it would recognize that, adapt, and provide a new set of recommendations. It delivers that to a web dashboard. And so that web dashboard, the operator can log into that dashboard. It will see the recommendations. The operator can then take them, Joe in this case, in our use case. He can take those recommendations and put them into his SCADA system. But you may ask, well, what if Joe doesn't want to always log into the dashboard? That's not a problem. We do have customers who put it up on their control room TV, but we also have customers who have operators who are out on the field or out in the plant a lot of the day. So we also have an option to send you, every couple hours, we'll send you the next set of recommendations to implement directly to your phone. So it makes it a lot easier for the operator to kind of ingest them during the day, review them, and then take the time to implement them. That's a quick about how it works. And then next question that folks usually ask is, does your site qualify? So this is an interesting one. So given that we talked about implementation a lot of folks will ask, well, what do I need to qualify? We actually have a handy little video here that I'll start playing that kind of goes through a bit about how your site will qualify. And we have it available online. I think we can share the link after, but you can go here, you can fill out a few questions, which I'll talk through shortly, and it defines what is the payback expected at your site. So first we'll start, I think we gather a bit of information just to get your name and your email, because generally we need to follow up with you to get into more detail about how what the savings would be. But we'll get here, and this user here will fill it out. John Innovise will fill this out for us. So what we're going to do here is we're going to ask you some qualifying questions, the type of your plant, etc. And ultimately we can provide you a high-level estimate of savings we can achieve immediately online, and then we'll follow up with you directly to really dig into those savings and see what data you have. So we'll go to the next screen. So we'll ask you which location, where in the world you are. That's important because the price of energy and chemicals changes. We'll ask for a name of your site. So generally we want you to think of a specific plant you have when you're thinking about this. We'll ask the type of the site. Is it water treatment, wastewater? Is it a distribution network? I think we'll go with wastewater here, which is really what we've been talking a lot about today. And here's a great qualifying question. Do you have remote control of your assets? So commonly we find this in plants. It may not be as big of a deal to have remote control because you can physically get to the blowers and the pumps pretty easily. But the more opportunity you have for remote control, the more savings we can usually achieve. What kind of sensors do you have? Do you have just inlet and outlet quality analyzers? Do you have only outlet, only flow metering? The more sensoring you have, the more opportunity for optimization. We also ask, what's the daily flow rate of your site? So in megaliters per day, what's about the size of water that you process and push through that facility daily? Then energy. Energy is a big one for us. So we're going to want to understand what's the monthly energy usage you approximately have in that facility. and then we can use that as a guideline of what is the available opportunity to optimize. And then very tightly tied to that is what is your energy tariff structure? So if you have a flat rate energy tariff structure, it's constant, there's less opportunity to optimize. If you have a variable with peak power, then there's definitely more opportunity to optimize. It depends what you have. Most customers have some kind of variable structure. And then as a corollary to that, what is the type of metering you have inside your facility? Is there no power metering? Is it just for the entire system? Is it sub-metering? Sub-metering is preferable, but not required. So now we'll switch tracks and get into chemical usage. So kind of what's the monthly chemical usage you have at your facility that you're using? So this will help us get an idea of what we could optimize when it comes to chemicals. The next one here, and I think, okay, so we're done. So for this site, so we think we can save about 9% to 18%, but we can dig in with more data of your system. But this will send you a quick report of what the expected savings would be, and then an Innovyze expert will follow up with you and talk a bit more. So it only took us about, 3 minutes there to fill that out to get an idea of what the savings could be, and then we can progress to the next step and really dig into that site and see what the opportunity would be there.
Fantastic, thanks James. We've had a lot of questions come in while you were doing that, so thank you everybody. I've been furiously working away behind the scenes here trying to group them, and they do group quite nicely into 2 or 3 categories. So James, I'll if you could take these ones, the first 2, quite a lot of people looking after Joe, actually. That's quite interesting to see, worried about poor old Joe. 2 questions, I'll read them both out, but they're essentially asking the same thing. Would AI make decisions on its own, or would it require configuration from an operator to make any changes in the plant? And associated with that, do you have an aspiration to offer closed-loop AI control where Joe can ideally do other work and only keep an eye on things?
Yeah, that's a great question. So today, we commonly operate in what we call advisory mode, where we give those recommendations to Joe, and he reviews them, makes sure that he's happy with them, and then implements them. We do have on the roadmap to do a full automated control, where Joe at one point may say, okay, you know what, I'm trustful of the AI now. Let's do automated control. So we do have the ability to integrate with your SCADA system with an OPC UA server and have the AI push those recommendations right back to your system. So that capability is there. But usually today we want to work with Joe initially and make sure that Joe is happy with those recommendations before we go anywhere near the automated control part. So that's what we'll do there. I think that answered most of the question. Yep, Andrew, was there? Okay.
Okay, yeah, the other one that came up as a common theme, and again, thank you for all the questions, it's truly amazing. Is this only suitable for a cloud-based solution, or can it be installed on a client server and interfaced with SCADA on the same secure server?
Yeah, so generally we deploy to a SaaS world. We found most customers are moving to the cloud as well. So it is possible, it would be possible to potentially do this, but I think we normally would just want to stay in the SaaS world. There's a lot of stuff we leverage in Amazon Web Services. We're a cloud native company by nature. So we leverage a lot of their services. There's a lot of stuff we pull, a lot of the data we pull in, such as the weather data, comes from the internet as well. It's not something that we could source internally inside your network very easily usually. And even other local event schedules, energy tariff may also come externally. So usually we'll try to stay in the cloud. That's where the product best operates. But if you have specific requirements, we'd be happy to talk more about them.
Okay, thanks, James. And another one, which again was asked in a variety of different ways, but people are, a lot of people actually are rather unsure about the quality of their data feeds, which could potentially be helping to educate the AI system. So a lot of the questions were like this one, which said, how do you deal with missing or errant data when training the AI from the historian?
Yeah, so that's a great question. So every customer's data is different. I think every customer gets that. Everyone knows they have some bad data somewhere in their system. So that's part of the implementation process. We will go through and review that data with you and identify where those issues are. When there are gaps or missing data, there are usually ways we can work around it. So a common way is if we're missing a gap in a sensor data at a pump, maybe there is some surrogate data downstream or upstream that we can leverage that is representative of the system. And it may not, in your mind, in a human's mind, it may not be representative, but the AI may actually identify a different surrogate data than you'd think. And usually we can find some kind of surrogate data to represent how that variable has been operating in the network. So there's usually ways around it. Another way is once we recognize the way it operates, a lot of the time the AI, we can also create what we call a virtual sensor. And we know how the aggregate system works. We know what the inputs are and the outputs, but maybe we're missing a portion of the middle of the process. A lot of the times the AI can generate a virtual sensor that represents how that middle portion works, and so we can fill that in as well. So there's a couple of different strategies we have there. So I wouldn't be, I'd be concerned about that, but I'd say let's talk more, and we've got some pretty smart machine learning engineers who can usually figure out ways to instrument the AI and get it to fill in those gaps.
Fabulous, thanks, James. Well, I think we'll do one final one because this came up a couple of times as well. Just harking back to when you were talking about the proof of concept and where that stage is. During the POC period, how do you demonstrate the expected savings over such a short time frame, given many other variables will be driving overall energy use?
Yep, yeah, that's a great question. We get that one a lot. So what we do is we used a couple factors. So since we already have 2 years of your historical data, we can establish a baseline. Let's say if the 30 days happens to be the month of June. So we would have how you operated 2 years ago in June and 1 year ago in June, and we can use those as baselines. And then we'll compare that to how you're operating this year, remove any difference in operation mode. So if you processed twice the volume last June than you did this June, we could adjust for that. And then given that we have that ability to baseline what historical performance was versus now with the AI, that's one way we do that. And then we'll extrapolate that to the rest of the year. Again, leveraging the fact that we have that 2 years historical data, how you have operated. So that's commonly how we'll prove that in such a short time, because we're able to kind of use that historical data to leverage and baseline what historical performance was.
Fabulous. Thanks, James. I'm conscious that time is ticking. So again, thank you everybody for the large number of questions. I very much appreciated. We will, as I said earlier today, get back to each of you individually on your specific questions. So thank you. Do keep tapping them in. But at this point, I think I'll let you just hand over the reins back, in fact, to Ben, if you could help us with a little bit of wrap-up.
Yeah, brilliant. Thank you very much, James and Andrew. A big thank you for everyone to attending today's webinar. I'm sure many of you, as Andrew said, still have questions about AI, and we intend to cover them in more detail in the next in our series of Water Talks. Water Talks are live interactive events where you get to ask questions of our experts on the big issues in our industry today. So please join us next Thursday at 1 p.m. via the link I shared in the chat interface. Also, remember to check out our upcoming training courses. As always, visit our website for more details about those. And finally, a big thank you today for joining us. And I hope you found the webinar useful, and wish you all a great day, everyone. Thank you very much.